This is the in-class notes for Chapter 5. These are for students who are absent or want to refresh on previous material. So in this example, we want to make a box plot for each of these data sets. So you want to start by making two lists in your calculator and run one variable stats for each to create the 5-number summary for set A and set B. If you don't remember how to do this, in your packet, there's the Unit 1 calculator tutorial that runs you through how to create a 5-number summary and how to create a box plot. These are the 5-number summaries for set A and set B. Okay, if you get something close to this but not quite the same, just check to make sure those numbers are put into your calculator correctly. Now, first thing we want to do here is find the IQR for each of these data sets. IQR is Q3 minus Q1. 39 minus 33 is 6. I'm going to write it right next to the A there. Over here we have 49 minus 39 is 10. Okay, and we want to find the fences. So lower fence is quartile 1 minus 1.5 times the IQR. Upper fence, quartile 3 plus 1.5 times the IQR. We're doing it for set A first, so that's these numbers here. We get a lower fence of 24, so anything below that is an outlier, which means 22 is an outlier. Upper fence is 48. Anything above 48 would be an outlier, but we don't have anything above 48 because our highest number is 47. Do the same thing with data set B, and we get 24 and 64. Okay, and we see we don't have anything below 24 or above 64 in data set B, so there's no outliers in data set B. So we want to make what's called parallel box plots. Okay, and we want both box plots on the same graph. So first thing we want to do is draw the scale. Okay, and we want our scale to be large enough where it can fit both of our data sets. So we need to go from 22 to 59 because this is our lowest number. This is our highest number across both data sets. So let's say I'm going to start at 20, okay, and go to 60. Let's see, right in the middle of that would be 40, 30, 50. Okay, we want to make sure that these are at least somewhat spaced out evenly. All right, now to draw feed A first. Okay, we have our box in the middle, which is going to go from 33 to 39. Might be a little short on the 39, but close enough. And then to 37.5, which is about there. And then our whisker on the left goes to the smallest number that's not an outlier, so down to 30. And then we have the outlier at 22. Okay, whisker on the high side goes up to 47. Okay, we want to label this so we know which one it is, so let's put an A on the left there. For B, it's going from 39 to 49. I'm going to keep 39 there since that's where I drew the other one, even though it should be a little higher than that. Up to 49, which should be about there. And let's see, whisker up to 59, and then left whisker down to 35. And this is B. Okay, so when we look at these, we can see that they're both skewed to the right because those right whiskers are a bit longer than the left whiskers. All right, we can also see that the pigs in that 8 feed B are heavier than the ones that 8 feed A. Actually, the top 25%, the heaviest 25% of pigs that 8 feed B, weigh more than all of the pigs that 8 feed A. Okay, we can make comparisons like that. So back to standard deviation. This was the equation, and I had mentioned that we're never going to actually use this. Okay, we're always just going to let our calculator do it. When we make that list in our calculator and we run one variable stats, okay, it gives us the standard deviation. There's also something called the variance, which is just the standard deviation squared, or conversely, the standard deviation is the square root of the variance. When we have data sets that are tightly clustered around the mean, around the center, variance and standard deviation are going to be small. If they're spread out, variance and standard deviation are going to be large. So remember, anytime that we have a quantitative variable and we're asked to describe it, we use the acronym SOX, shape, outlier, center, spread. Okay, now when it comes to the shape, we want to pick our center and spread deliberately. Okay, if the shape is skewed, we use the median and the IQR. Okay, if we have a unimodal and symmetric shape, we report the mean and standard deviation. If we want to give the median an IQR, we can, but mean and standard deviation are the appropriate measures of center and spread. Lastly, the mean is the balance point of a distribution, whereas the median is the halfway point. Outliers pull the mean towards them. So if we have a symmetric distribution, the mean and the median are essentially the same value. When we have a distribution that's skewed to the left, we have values on the left side that are acting kind of like outliers, even if we can't mathematically identify them as outliers. So that being said, the mean is getting pulled towards that skew, towards the left, and it gets pulled lower than the median. Okay, in a skewed right distribution, the mean is pulled to the right, so the mean is larger than the median. So looking at the shape of a distribution, we can always give some kind of answer as where the mean is with respect to where the median is.